50% of the CBSE math paper is competency based. Welcome to our Pro Competency Series Part 2. The first question for the day. Find all the pairs of positive integers whose sum is 91 and HF is 13. So here we have two numbers A and B whose sum is 91 and HF is 13. So which means the first number would be a multiple of 13 and second number would also be a multiple of 13 given that x and y are co-prime. This is essential such that the HCF remains 13 itself. Now as we are given here, the sum is 91. 13x plus 13y should give us 91. When we simplify this, that is when we divide throughout by 13, we would get x plus y is equal to 7. Now let's look at some possibilities when this is true. The first possibility is 1 and 6 would give us 7. The second possibility of 2 and 5 would give us 7. And the third possibility of 3 and 4 would give us 7. So substituting these values, the first set would be 13 into 1, which is 13, and 13 into 6, which is 78. So 13, 78 is the first set of numbers. Then likewise, 13 into 2, which is 26, and 13 into 5, which is 65. So 26, 65 are your second set of numbers. For the last set, 13 into 3, which is 39, and 13 into 4, which is 52. So 39, 52 is your third set of numbers. 13, 78, 26, 65, and 39, 52 are your three pairs of numbers possible here. Moving on to the next question, where we have a question based on polynomial, where we have a polynomial 2x square minus 6x minus 3. The zeros are given in the form of 3 plus or minus root of k by 2, where k is any real number. So using the relationship between the zeros and the coefficient, we are supposed to find the value of k. So here, let's use the relation of the product, because the sum of zeros would eliminate the value of k itself. So let's use the relation alpha into beta, which is c by a. So here the first zero is 3 plus root k by 2, and the second zero is 3 minus root k by 2, which is equal to constant by constant, which is minus 3, and coefficient of x square is 2. Let's simplify this. You can take out 2 here. The numerator would turn out to be 9 minus k by 2, which is equal to minus 3. On cross multiplication, we would get 9 minus k is equal to minus 6. That would imply 9 plus 6 is equal to k, or I can conclude that k is equal to 15. Then for the last question that we have, x square minus 3 root 2x plus 4 by x minus root 2, where x is not equal to root 2. Here we need to look at how many points does the graph of above expression intersect the x-axis, and we need to show our calculations here. So here if you look at the numerator can be factorized, which is x square minus 3 root 2x plus 4. We can split the middle term as x square minus 2 root 2x and minus 1 root 2x plus 4. So here we can take x common, that would leave us with x minus 2 root 2. And here we can take minus root 2 common, that would leave us with x minus 2 root 2. So on solving further, we will be getting x minus root 2 and x minus 2 root 2. This is our numerator. Now the denominator, as we can see here, the denominator is x minus root 2. So if we divide this by x minus root 2, you would notice that we can cancel the factor x minus root 2. We will be left with x minus 2 root 2. And this when we equate it to 0, we will be getting x is equal to 2 root 2. That is, the given polynomial here will intersect the x-axis at only one point, and that point is x is equal to 2 root 2. So if you want to be a pro at solving these kind of competency-based questions, do follow, subscribe, and press that bell icon so that my videos reaches you directly at your notification. So see you in the next video.